absolute basics of significant digits. Step one. If I said, let's say I have a truck scale, okay? So I drive onto this truck scale, and the truck scale says that this is 1,000 pounds and this is 2,000 pounds. It's a really light truck, all right? And the little pointer points here. What is that? Maybe it's 1,200, maybe it's 1,300. I wouldn't go any further than that. But the trick is, I don't know which hundreds place that is, because it measures the thousands place, but it doesn't measure the hundreds place. So the hundreds place is a guess. Okay? Now, if on the other hand, I pull onto the same truck scale, and the pointer's here, same place. Now I say it's okay. If the 1,000 is good, I know the 1,000. I know the 100. It's between 200 and 300, so it must be 1, 2 something. And now I go, it's about 8. So now the tens place is a guess. Okay, so depending on the scale you're using, that's how you figure out how many numbers you get to keep. So the idea is always all the ones you know plus one guess. All the ones you know plus one guess. So up here, the guess was the 12 or the 13. We don't know. It's someplace in there. Down here, the tens place is the guess. So I can't write anything in the ones place because I'm already guessing the tens place. Okay, so that's the idea behind significant digits. So whatever scale you're using, you do all the ones you're absolutely sure of, and then the next one's a guess. Okay, so that's the first piece of this. Second piece of this is there's some simple rules for when we look at a number. If I look at a number and the numbers any number 1 through 9 is written and it's already significant, it's already written the way it's supposed to be written based on this, any number 1 through 9 is significant. The zeros get a little weird. Okay, notice over here, those zeros, they're not significant. Okay, because remember we said that it was anywhere between 1,200, 1,300, someplace in there. So we have no idea what these numbers are at all. They're beyond the guess. This is my guess. We stop at the guess. So those two numbers, not significant. Their only purpose is what's called a placeholder. And they're not significant. Okay, because 1300 has these numbers in it just so that they keep the 1 and the 3 off of the decimal. That's their job. To keep that 1 and that 3 off of the decimal. Okay, now I'm going to do something to make this a little bigger. Hold on. That'll help. That'll help for the recording. Now, so the same drill goes to the other direction. Like if I go 0.0013, it's a really small number. Those zeros are just placeholders to keep this in the right place. Okay. Now, if on the other hand, I had some scale that said this is 13, right? And this is 14, and the pointer's right there, I would say it's 13.0. Now, that number, not a placeholder. These guys are, because you see what they're doing, they're kind of standing between, picture it as people. These two are standing here being real numbers. Let me show it as the right color. These are being real numbers that we care about that are significant. But But these guys here are just standing there to keep, these are some misshapen people, to keep them off the decimal. But notice, this guy is real, this guy is real, and this decimal is here, so there's no, that 0 is not there to keep something off the decimal, so it's real too. So this thing has 3 significant digits. Okay. But anytime you have questions, stop me. Now, so that takes care of that. If I go 13.01, that one is still significant because it's a number. This one is because it's between two numbers that are 1 through 9. Okay, because it is kind of keeping that 1 off the decimal, but that's real. This would mean that I've measured it down to the 10th place, and I'm guessing the 100th place. So all 4 of those numbers, this has 4 Sig Digs. Okay.
I'm a little confused though, because you said that the 0 was supposed to be a placeholder. So
okay, now watch. Here's the trick. Here's the caveat, the not correct piece of that. If it's between two numbers 1 through 9, it's no longer really a placeholder because it was measured. We actually measured it. See, like here, go back here to this. This is the screwy part of Sig Digs. Over here, we can't measure those zeros because the scale only measured 1,000 and 2,000. We were guessing the hundreds place. This one, if I actually drew the scale for it, this would be like 13. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 16 or 14. And it's just the tiniest little bit past 13. So the 1 and the 3 are good because it's between 13 and 14. The 0 says it hasn't gotten all the way up to 13.1 yet. And we're saying it's not exactly on, so this is measured. So this is not exactly on the mark. So we're going to say it's 13.01. So it's a little bit more than 13. Okay. So we really did measure that 0. So it's not really, I mean, it is in a spot, but it's not holding place. It's actually, we measured the 1, we measured the 3, we measured the 0, and we guessed at this 1. So that's the big difference. That's the thing that always mucks people up when you're told to just count the stupid things. Okay? Because they look at this and they go, that's only got 2 significant digits because it's got this and this. This has only got 2 significant digits because it's got this and this. Those guys are just placeholders. These guys are just placeholders. This one has 4 significant digits because we really did measure that 0. It's not a placeholder, it's real. And that's the hardest thing to get a hold of with these significant digits. It's always all the ones you know plus a guess, so I know that's good because I measured it. And then I guessed that. Okay? So the rules are pretty simple. If it's 1 through 9, it's significant. It's a placeholder, it's not significant. But if it's between two numbers, 1 through 9, it's significant. Okay. Now, next piece of this. There's a better way. If I were going to write, you might be familiar with scientific notation. If I were going to write that, I would write 1.3, and then I move the decimal 1, 2, 3 spaces. So it'd be 1.3 times 10 to the 3rd. And this shows that only these two numbers are significant. Because this just tells me where it is on the number line. This doesn't measure significance at all. This just says it's over there 3 places more than what it's showing. Or like the other one would be 1.3 times 10 to the, let's see, 1, 2, 3, 10 to the negative third. And so it would only have these two significant digits. If you get that, the adding and the subtracting are real simple rules. But you got to have that under control for any of the rest of it to work. So rule number 1, what is a new color? Pink. Number 1, 1 through 9 are significant. Number 2, if it's just a placeholder, not significant if it's a 0. Rule number 3, if it's between two numbers 1 through 9, it's significant, even if it's a 0. Okay. Now, the adding and the subtracting thing, or the multiplying and dividing thing, the adding and subtracting thing makes sense once you get it, because it's no more than this. Watch. If I said I did a couple of measurements and I went 14.5 and my other measurement was 1.623. So in this one, I used something that measured to the ones and guesses the tens. But the point here is that it has a significant digit in the tens place. The other one I measured really accurately. I was really good. And it measured all the way to the thousandths place. That color is terrible. Better? Not better.
Yeah.
Better-ish. I want to do better, period. There we go. Okay, now, here's the deal. Remember what I just told you. All the ones you know plus a guess. So we come across this first number, the guess is the 5. And I'm using that stupid green thing again. Get out of here. The guess is the 5. This one, it's all the ones you know plus a guess. So let's say let's say I'm subtracting them just for giggles and grins. So this would be 12 carry the 1, 877. Okay, now here's the trick. That's a guess, so that's a guess. This is a guess, so we added it to a number or subtracted it from a number. That makes this a guess. That's where you got to stop, because you're only allowed to keep one guess. Okay, so with addition and subtraction, if you just stack them up like you normally do back when you were in like elementary school and you got taught to add and subtract, you stop after the first guess. The furthest this way, if you will, the furthest to the left. The first one you get to where you run out of digits, you stop. That's it. You're done. These don't count. Because they're beyond the first guess. So they're like guesses about guesses. Okay? Now, the other thing somebody might say is, well, Mr. Rippeon, that's 12.87. Shouldn't we round that? And you're right, you should. So we'll make it 12.9. If it had been 12.87 or 12.82, and that's where you were supposed to stop, it'd just be 12.8. That's all it is. You just, with add and subtract, you just go across till you run into the first thing that's a guess and stop. Done. Good?
Yeah.
Okay. Multiply division, even easier. way. I'll just get rid of this little bit here. If I go 42.1 times 1.7. Got no idea what that is. Where's the calculator? Somebody stole my calculator. You got a calculator? Figure out what that is. I'll see if I can do it in my head.
Is that 42.1?
42.1 times 1.7.
I got 71.57.
I am good. I did it. See? Anyhow, who cares? Now, here's the point. We count them. 1, 2, 3. Got 3 significant digits. 1, 2. Got 2 significant digits. Take the smaller one and make that the number your answer has. 1, 2. Got to stop there. So it's going to be 71.5. So it's going to be 72. All you got to do, just count the significant digits. And the one that has the smaller, that's how many your answer is allowed to have. Now, I could prove that to you by showing you with a bunch of math and magic, but who cares? The point is 3 and 2 makes 2 significant digits with multiplication and division. Okay, with add and subtract over here, it's stop at the first one. That's all it is. Okay.
Okay, so the smaller one is the one you use for both, right?
Well, not necessarily, because watch. If I do an add subtract, if I go 145.72 and 12.8, and I'm supposed to add those, that's going to be 158.52, right? Well, if I'm adding those two, notice that's the smaller one. Oh, that's wrong. That's not good. That just proved what you just said. So let's make that here. Now they're the same size. Start over. Let's say I said it's 1.786 plus 2,121.1. I don't know. I just made that up. 2,122,886. Okay, I just added them. This is the bigger number, but notice this is the first guess, or the guess in this number. This is the guess in this number. So we stop here. Even though that's the bigger number, when you hit your first guess, you stop. And so this would be 2122 point, and since it's 88, we'd make it 29. Okay, so when you hit the first guess, you stop. Over here, it's the smaller one. Absolutely. Multiply, divide, it's always the smaller one. Over here, if it's add or subtract, you go over till you hit your guess. You go over till you hit your guess. When you hit your first guess, you stop. Okay. Now, I'm going to stop recording so that you can ask questions and we can do a couple of examples. All right.